Esri. I want to start by thanking you all for your time today. I'm excited to present to you on our journey of injecting 3D into Victorian planning. By way of introductions, my name is Justin Maddox and I'm the manager of the Spatial Services team at the Department of Environment, Land, Water and Planning in Victoria. My team is made up of 17 spatial experts with a variety of skills and experiences. We're basically the planning group's spatial team and go-to point when it comes to anything that relates to mapping. Over the next 25 minutes, I'm going to share with you our journey of enhancing our spatial implementation. This journey has been one of great learning, and I'm really keen to share with you the lessons we've learned along the way. Victoria's Planning Department manages a range of complex statewide datasets. As little as 3 years ago, we were working ineffectively using outdated technologies and not embracing GIS to its full potential. Over the past few years, we have invested in the ArcGIS stack to allow us to more efficiently manage the datasets through desktop and server-based tools, along with enriching the planning experience through the spatial analysis capabilities now available to us. So what are the planning group's spatial services team responsible for? Well, firstly, managing and maintaining the Victorian planning scheme, but more on that in a moment. Providing a mechanism for the Minister for Planning to review permits and applications across the city, in particular undertaking visual assessments on how these new developments will impact their surroundings. And of course, providing advanced spatial analysis to the planning group, be it in the form of raw data or high-end cartographic products. And what's the current state of spatial and planning? Well, as a result of our migration onto the ArcGIS platform, we have a comprehensive ArcGIS implementation which spans desktop editing, cartographic map creation, ArcGIS server-based web services, and targeted web mapping applications. Along with this, we have a bespoke and disconnected 3D solution, which presents challenges when integrating key spatial datasets. The team itself is a group of passionate, dedicated, and highly skilled spatial developers and analysts. And we're also really lucky to have an engaged stakeholder group and a really supportive executive and management team. The Victorian spatial representation of the planning scheme is a complex dataset to maintain and manage. With weekly updates submitted alongside an ever-changing cadastre dataset, a lot of effort is required to ensure it's accurate and up-to-date. At a high level, it consists of 83 schemes across the municipalities, over 50,000 planning zone polygons, and over 80,000 planning overlay polygons. By leveraging the full potential of the ArcGIS spatial tools available to us, we've been able to introduce a great deal of efficiencies in our management of the planning scheme, minimizing manual tasks and ultimately directing attention to more high-value work. But one area that was still disconnected and difficult to utilize fully was our 3D platform for visualization and analysis. The time had come to re-evaluate our 3D implementation, but we quickly came to the realization that it was time to not only review our internal 3D platform and capabilities, but how we engage with other government departments, municipalities, and the private sector. We recognize there is a disconnect in how data is being used by governments, industry, and the community, often resulting in unintended disparate outcomes. The issues as we saw it were different parties are maintaining their own 3D base models in isolation. These groups are using conflicting tools to perform their spatial analysis, and many of the existing solutions are extremely complex to operate and limit the ability to collaborate and share data. We identified a clear need for a consistent platform and statewide 3D model that allows all levels of government and the broader community to perform analysis and visualization on an existing built form, proposed developments, and overshadowing impacts. We propose to build a scalable 3D platform to enable our stakeholders to collaborate, easily analyze, and visualize the future of Victoria. The solution was to consist of a 3D web mapping platform and a detailed statewide dataset developed in collaboration with municipalities around Victoria. Additionally, the solution would provide a high level of accessibility. It needs to be both available on devices we use every day, but also intuitive for anyone to use without the need for lengthy training. Tapping into existing DELWP expertise and partnering with councils, our objective was to work collaboratively to provide an innovative and fit-for-purpose solution. We could see what the problem was, and we'd identified our end solution, But how exactly were we going to get there? Well, just like baking a cake, we wanted to ensure we had the correct ingredients before commencing the project. As a team, we identified what are the key elements that are ultimately going to help us make this project a success. And first and foremost, it was going to be data. There are plenty of 3D tools and technologies on the market, but unless we have the fundamental data sets and stipulated data management strategy, we were going to be setting ourselves up to fail. We needed to determine a way to build out a full 3D base map for the state of Victoria, which is no easy feat. And of course, we also needed to provide some rules and recommendations around the format of 3D development activity, building models, and BIM models being submitted to the department. Next was technology. One of the early tasks was to review what are the available 3D tools and technologies on the market, assessing the pros and cons of each. A lot like selecting a football team, where you want to ensure that you cover all ends of the ground and not end up with just a bunch of goal kickers. We needed to ensure the technologies we chose were going to be able to meet all facets of our requirements instead of just excelling in a few finite areas. The key aspects that we were assessing included: does it provide the functionality we require out of the box, or is it adequately configurable to support our requirements? Is there a solid roadmap? Will it integrate within our spatial environment? And what is the reputation of the product stack? And of course, the third ingredient, people. We might have the highest quality data and we might have the greatest technologies available, but without a user base that's engaged in the journey, there wouldn't be any success. Additionally, it's essential to have a team of spatial experts to not only drive the development, but support the maintenance and enhancements of the solution into the future. And of course, collaborating with other parties working in this space would not only allow us to share our learnings, but also learn from others who are leading the pack in this space. So altogether, we're aiming to deliver a highly accessible, robust and powerful, modular and extensible 3D spatial platform. Along with the key ingredients, our project plan outlined a series of steps that would ideally give us our best chance of success. Personally, I'm quite risk adverse, so I wanted to ensure that we were tackling this project in a structured fashion, identifying potential issues early and working collaboratively towards a solution. So step one, commencing in middle of 2019, was where we spent considerable time working with our stakeholders to understand their end-to-end requirements, what their current tool set does well, what it could do better, and ultimately what they would like to see into the future. Following on from that, step two, based on our assessment and review of the technologies and tools available, we settled on a series of elements which we believed could deliver what we required. But before we went too far, we embarked on a proof of concept to validate the preferred technologies. As I mentioned, I'm quite risk adverse, and I know all too well that the marketing material that comes with some tools can sometimes overstate their capabilities a little. So I felt it was imperative that we ran our chosen tools through their paces. And step three, once we were satisfied with our chosen technology stack, we developed a technical design and commenced the implementation of our 3D spatial solution. We tackled it in an agile methodology fashion, which was in line with the development of our other spatial applications. Once we had a solid understanding of how the business operates and what are their key requirements, we performed an analysis and experimentation phase, developing a proof of concept, which you can see now in the video. We wanted to test our chosen technology to ensure that it could deliver what our users were after. And some of the initial components we focused on were the integration of 3D and 2D data, including aerial photography, LiDAR, and the planning scheme, developing tools to interact with the 3D base models, providing the ability to easily visualize highly detailed development models alongside the existing built form, and the ability to mock up proposed developments within the interface. Upon completion of our experimentation phase, we documented our findings and produced a design for the formal solution. We were satisfied that our selection of tools and technologies would be able to deliver the solution we were looking to implement. So what were the technical elements that we planned to use? Well, firstly, the ArcGIS JavaScript API. This API provides a great deal of functionality and tools out of the box, and it also has an exciting roadmap. It also allowed us to easily integrate with our other spatial systems and services within planning. Secondly, ArcGIS Pro. This provided us with a great range of data analysis and data management capabilities, and it works well with our strategy to fully migrate off ArcMap and onto ArcGIS Pro for all of our services and operations within the next 12 months. The ArcGIS solution for local government. This is a real hidden gem from Esri, and it provides a great range of tools to support planning and development. The key areas that took our interest as part of the suite were the ability to publish 3D base maps and the Assess Development Impact module, which is a collection of maps and apps used to assess the physical impact of each new development on the existing community. ArcGIS Urban. As soon as we saw the first demo of Urban more than 2 years ago, we were really excited to see how this could empower our planners and ultimately enrich the analysis capabilities in the area of urban planning and design. The key reasons we opted for the chosen technology stack included technically it was able to deliver most of our requirements. Unfortunately, there was no single technology stack that could do everything perfectly, but this stack would provide us with some really great tools immediately and with little configuration effort to get started. And the stack aligned with our broader spatial strategy within the department and would integrate seamlessly alongside the rest of our spatial implementation. And it would also allow for a greater return on investment in our spatial environment, both from the technical implementation, but also the development of the team in the ArcGIS stack of technologies. One of the key objectives was to not only deliver the solution, but upskill the team across the various aspects of the project. I'm going to now spend a little bit of time walking through each of the key areas of the solution in a bit of detail. And firstly, data. We realized early that the success of this project hinged on a solid data schema and data management strategy. With our solution not being solely focused on metropolitan Melbourne, we knew we had a large task ahead of us to not only build out a 3D base map for the whole state, but also to provide other data sets that would aid in analysis that's needed to be undertaken within the application. The key steps that we followed throughout this phase of the project were, firstly, identifying what data sets we have available and determining what are the gaps. Within DELWP, we have a great wealth of data, so we wanted to ensure we leveraged this first and foremost. Secondly, we needed to build out our 3D base map using the available tools, technology, and data sets. Third step was to ensure our data management strategies were robust, automated, and streamlined. We wanted to ensure from the start that we had solid methods in place to manage the data and eliminate any manual processing and publishing of data. And fourth, recognizing the value in collaboration when it came to building up our 3D data footprint. It's worth acknowledging the great support and work done by our partners like City of Melbourne and Aerometrics, who have been fantastic in sharing their knowledge and learnings with us along the way. The ArcGIS solutions for local government provided us with some great tools to use out of the box with ArcGIS Pro. The team was able to leverage these powerful features to fast-track aspects of the project implementation. For those unaware, the ArcGIS solutions for local government include a series of focused maps and applications designed to help us leverage our GIS information and the ArcGIS platform to improve government activities and ultimately enhance the services delivered to the general public. We focused on the following modules: the Publish 3D Base Map module and the Assess Development Impacts module, and specifically the ability to evaluate shadow impacts, conduct visibility assessments, and calculate solar radiation, all things that the Minister for Planning has a very keen interest in when assessing proposed developments. By integrating these tools with other tools and processes, we were able to build out a full statewide 3D base map that is used not only in Vic3D, but also our other web-based mapping applications. I wanted to highlight some of the great features of this solution and how it benefited us now. The solution can determine the aggregated shadow for a defined area, and then taking a proposed development, determine the shadow introduced by that building. Deriving the aggregated shadow for the new building, it can provide details of the new level of shadow introduced. And this can be further refined to highlight areas that have just had more than 2 hours of extra shadow introduced. This can be used to determine the impacts on existing structures like neighboring buildings as well. Using our built form and Using our built form, the solution was able to provide detailed shadow information over the course of defined days, and this allowed us to visualize the impacts of a new development on existing buildings. Utilizing the included geoprocessing tools and tasks, we could determine the level of shadowing introduced for the existing buildings. Another element that we are keen to explore further is the ability to perform visibility assessments through this solution. Taking a new development and features such as a lake or a river, the level of visibility can be calculated by the solution. And this could also be leveraged for determining the ideal location for features such as CCTV cameras, calculating the level of visibility based on where they're installed. Overall, the ArcGIS solution for local government was a really powerful and easy to use package that streamlined a lot of analysis that would have typically taken far longer to deliver. In regards to the web application Vic3D, the focus areas for version 1 included visualization of existing built form alongside development activity, shadow analysis capabilities, measurement tools to calculate distance and area in a 3D space, a toolbox of features to provide visual assessments on line and sight and viewshed, sketch features to model potential developments without a proposed building model being submitted, and camera tool capabilities to set up defined viewpoints and perform fly-throughs within the interface. I'd like to showcase some of these features for you now that have been delivered as part of version 1 of Vic3D. As I've mentioned, it's a statewide 3D viewer built using the ArcGIS stack of technologies developed to be easily accessible through a web browser. The application incorporates existing built form models, proposed building and BIM models, highly detailed mesh models alongside the Victorian planning scheme and other VicMap datasets. We wanted to make it simple to visualize development activity and their status across the state, so we settled on markers which would bring in the building models when clicked upon. Highly detailed mesh models were incorporated to deliver realistic context for priority areas across the state. And we also introduced measurement tools like the distance and area tools, which are available out of the box from the ArcGIS JavaScript API. We also incorporated visibility tools which support operations such as performing a viewshed analysis for a user-defined location, or dynamically analyzing the view ray from a user-defined location and allowing the mouse to determine where you're looking, and also calculating the line of sight between 2 points from within the viewer. An exciting tool that we've developed is the sketch function, and this allows users to create and analyze proposed buildings within the viewer. Firstly, the tool will define the building footprint, which can be derived from property boundaries or drawn freehand. Then the number of tiers are defined with floor heights and number of floors set, and this includes different setback configurations for each building segment. All of these sketch buildings will then be available as part of the shadow analysis capabilities undertaken from within Vic3D Viewer. Alongside Vic3D, we are leveraging the capabilities of ArcGIS Urban to fully equip our planners with tools to further empower them when analysing changes to the planning scheme zones and overlays. Providing the ability to visualise proposed changes to the planning scheme or space use configuration and ultimately the overall performance of the planning scheme, ArcGIS Urban is giving us a powerful and intuitive tool to perform this analysis and planning in 3D. Working closely with Esri Australia and Esri Inc., we have made great progress in integrating the Victorian planning scheme into ArcGIS Urban and configuring the interface to support our planners. The key features that we're currently leveraging are as follows: the ability to view a digital representation of Melbourne, the powerful integrations with City Engine, the feasibility of creating and comparing design scenarios, 3D realm, and the capacity to gather feedback from the public on proposed plans and projects within the interface. Our strategy is for Vic3D and ArcGIS Urban to complement each other by providing a full range of tools to the planning group to support them to make informed decisions around the future of our state. So with the successful deployment of version 1 of Vic3D, we took a step back and reflected on how far we'd come and what were the benefits delivered to the department. Firstly, we've delivered a solution to our stakeholders which not only supports their current needs, but has also opened up a great deal of potential to do more analysis and ultimately have more data at their fingertips. As soon as a building model has been submitted to the department, it's now automatically published to the spatial environment and visible through Vic3D. Planners no longer need highly skilled technical people to help them review development activity. They can easily do it themselves whenever and wherever they need. If they're out of the office, they can easily bring up Vic3D and determine the overshadowing impacts based on a proposed building. And of course, planners can spend hours of fun looking at their own houses within the viewer and how the surrounding developments are potentially going to overshadow their property. Secondly, we've got a really empowered spatial team within planning. The team have had the opportunity to not only learn new technologies and skills, but they've been empowered to use those skills and benefit the planning group. And we've been able to deliver this project collaboratively, utilizing both in-house staff along with external parties. And at the end of the day, it's allowed us to play with some pretty cool technologies and toys along the way. But it doesn't end here. There are still a lot more exciting functions and tools to explore and introduce into our 3D solution. And some of those include enhanced shadow analysis. There are a lot of potential to further enhance what's possible through the analysis of overshadowing within the interface, including isolating the shadows for a single building and on-the-fly cumulative shadow determination. The introduction to visualize real-time data within the viewer. This will be a great support to planners in making the most informed decisions within the interface. And there's a focus on leveraging VR and AR technologies and integrating those with gaming engines such as Unreal and Unity for some really powerful and exciting visualizations. So after all that, what have we learnt along the way? Well, firstly, there's not one tool for the job. There is so many great components across the ArcGIS suite, and while it can be daunting to keep across all of them, it's worthwhile investing the time in researching what's available, along with talking to people who are experienced in the space. Watch the various webinars Esri release, read the blog posts they publish, campaign to your manager for a trip to the Esri user conference in San Diego, whatever it takes, because it's all worth it in the long run. Our research ultimately showed us that by combining various aspects of the ArcGIS stack, along with other spatial tools such as FME, we were able to build a really exciting and powerful 3D solution. Business case and management buy-in. Without a solid business case and strong management buy-in, we would have never got the latitude required to develop such an innovative solution. Availability and accuracy of data. As much as we'd all love to have the highly detailed mesh models and textured LOD3 models throughout our applications, you only really need data as detailed as your business case demands. Going beyond that only puts unnecessary strain on your system and your budget. But that said, some of the data sets that are being produced by companies like Aerometrics are simply amazing, and it's hard not to want them for your application, to be honest. Accessibility and user interface design. This is fundamental to the success of a project like ours. What you or I think is user-friendly isn't always user-friendly for a planner or the associated users. Ensuring the application is accessible on a range of devices and easy to use was a big contributor to getting our stakeholders excited and wanting to use Vic3D. And invest in your people. Projects of this nature are such a fantastic opportunity to fast-track the development of your teams. I've been so proud of the work done by my team throughout the course of this project, and I believe the investment in developing our staff will have positive consequences well into the future. And of course, collaboration. This project has demonstrated the value of a great collaborative working relationship, not only with the spatial team of planning, but across DELWP and more broadly. The success of projects like this are heavily dependent on us working together, learning from one another, and driving each other to bigger and better things. So in closing, I would like to thank you for your attention, and I hope that you've enjoyed coming along on the exciting journey that we've taken in terms of injecting 3D into Victorian planning. Thank you very much.